Astronomers made a startling discovery in 2012, and they announced it the following year. Using Hubble, they took very precise measurements of the movement of the Andromeda Galaxy, and they discovered that it appeared to be moving very nearly directly toward the Milky Way at a speed of 100 kilometers per second. They forecasted that approximately 4 billion years from now, the two galaxies would collide, and the result would be complete anarchy. Hey intellectuals, welcome back to the Future Space. In today's video, we are going to travel the Andromeda Galaxy and going to reveal some terrifying secrets. So stay with us till the end of this video so you don't miss out on any of this information. But before we proceed, don't forget to subscribe to our channel and click on the bell symbol so that you don't miss out on any of our wonderful videos in the future. And let's get started. In 2019, an update to the measurements suggested that Andromeda was sliding to the side a little bit more than was previously thought. This would postpone the inevitable collision by approximately 600 million years. However, more recent findings that make use of more recent data have recently been published, and these findings imply that Andromeda's lateral motion is still higher than it was previously thought. If what is being said is accurate, it is possible that Andromeda will completely avoid the Milky Way on this particular pass. The strange thing is that despite the fact that all of these measurements appear to be in opposition to one another, in reality, they all coincide with one another on some level. The problem that we are facing here is statistical uncertainty in the measurements, and the reason for this is that the numbers that are involved are very small and very difficult to determine. The Milky Way and the Andromeda Galaxy are the two largest galaxies in what is known as the Local Group. This group is made up of a collection of several dozen galaxies of varying sizes, all of which are held together by their own gravity. Since Andromeda and the Milky Way are the two largest galaxies, they control the gravitational pull of the group and will therefore determine its fate. For instance, if the two largest members of the group continually maintain the same distance apart from one another while they circle each other in a circle, then the group will pretty much remain the same over the course of time. If, on the other hand, the two are on a direct path toward one another on a collision course, then the composition of the group will be significantly altered as a result of this development. When massive galaxies collide, they hurl stars and gas in all directions, distorting each other into fantastic and bizarre shapes, and eventually merge into a single galaxy that is significantly larger than the others. The speed of an object can be broken down into two component directions: the radial velocity, which measures how quickly an object is moving toward or away from you, and the angular velocity, which measures how quickly an object is moving to the side, the transverse velocity. You should brace yourself for impact if something is moving toward you at some velocity but not moving transversely. On the other hand, if it has some positive transverse velocity, then it is moving both toward you and sideways at the same time. If the transverse velocity is sufficiently high, then it will not hit the target. Because nature has already provided a built-in method for doing so, calculating the radial velocity of Andromeda is a relatively straightforward task. Doppler shift occurs in light waves when an object is moving closer to you. This causes the wavelength of the light to become shorter. We call this blue shifting. By taking spectra of the galaxy, one can determine this with a fair amount of ease and accuracy, and it has been determined to be approximately 100 kilometers per second, which is equivalent to 360,000 kilometers per hour. Alright, but can you tell me what its transverse velocity is? What is the rate at which it is moving laterally? That's the most important question. In addition to this, it is very challenging to quantify. Andromeda is located at a distance of 2.5 million light-years, which translates to approximately 25 million trillion kilometers. Take into consideration this: Saturn is located approximately 1 billion kilometers from Earth, which is an extremely great distance. It took the Cassini spacecraft 7 years to get there. Imagine you traveled to Saturn and then returned to our planet. After that, repeat that process a billion times. Congratulations! You have only traveled the distance that is equivalent to 1/10 of the way to Andromeda at this point. Since Andromeda is located at such a great distance from Earth, any motion in the transverse direction will appear extremely minute, making it difficult to measure. The ability of most telescopes to even measure the minute shifts that occur in the positions of its stars over the course of a year is limited. To measure how quickly Andromeda was moving to the side, astronomers used Hubble to make incredibly precise measurements over a period of 5 to 7 years, and they obtained a velocity of 17 kilometers per second. This research was presented in the first paper that was mentioned above. This is a considerably lower speed than the radial velocity of 100 kilometers per second, which indicates that it is coming in our general direction. The latest data from the Gaia spacecraft, which measures the brightness, positions, motions, and colors of well over 1 billion stars with incredible accuracy, was utilized by astronomers in the newly published work. The method is difficult to follow, but in the end, they determined that Andromeda has a transverse velocity of approximately 82 kilometers per second. On the surface, this suggests that Andromeda will be sad to see us go. If the transverse and radial velocities are roughly equal to one another, and 82 is pretty close to 100, then this adds up to Andromeda traveling at an angle to the side of approximately 40 degrees, which is sufficient to completely miss the Milky Way. So, which one is accurate? Oh, now we get to the enjoyable part. As I've mentioned before, these measurements are extremely challenging and involve a great deal of guesswork. Astronomers are able to assign statistical uncertainty to their findings thanks to the variety of statistical methods at their disposal. For instance, the first measurements obtained with Hubble had a margin of error of plus or minus 34 kilometers per second. Therefore, the accurate measurement is 1734 kilometers per second, which is in line with zero. In other words, it is heading in our direction directly. However, in terms of statistics, any velocity between minus 17 and plus 51, think of it as going from a little to the left to going more to the right, is equally likely. Because of the way that statistics are calculated, it is impossible to exclude any velocity that is within twice the uncertainty. It's less likely, to be sure, but it's not even terribly unlikely, which means that a velocity ranging from negative 51 to positive 85 is still a possibility. The most recent findings from Gaia put the speed at 8,231 kilometers per second. Therefore, it could be anything between 51 and 113, and you can't rule out the possibility of it being anything between 20 and 144. That's a wide margin of error. It is also important to note that the measurements obtained by Hubble and Gaia statistically overlap. The low end of Gaia's numbers are overlapped by the higher end of Hubble's numbers. Therefore, despite the fact that the nominal measurements of 17 and 82 appear to be very far apart, we are unable to rule either out due to the large uncertainties. That is very irritating. If the lower number is correct, then that almost certainly indicates that there will be a collision. If the higher one is it, then there will definitely be a miss, and we are unable to determine which is which. The encouraging news is that figuring this out is not impossible in any way. The only thing left for us to do is wait. Seriously. The apparent motions of stars over time are something we are attempting to measure. The greater the amount of time that passes between measurements, the greater the amount of movement that occurs, and the greater the certainty of the measurements. Since the initial Hubble paper was published almost 10 years ago, it stands to reason that if it were to be repeated now, the numbers would be much more reliable. Gaia is continuing to gather information at this time as well. It is anticipated that updated data from Gaia will be released early in 2022, and another release will take place after all 5 years of the nominal mission have been processed. It is anticipated that the updated data will be significantly more accurate than the data that came before it. Consequently, if we give astronomers a few more years, these numbers should become more precise, and then, hopefully, we'll know for sure whether in an eon or 4 we'll need to either fasten our seatbelts for a cosmic collision or watch as Andromeda safely flies past us in 1 million or 2 light years away. We'll know for sure, we hope, when we get to that point. And that brings us to the end of this video. Feel free to let us know what you think about this video. And if you like this video, then please leave a like and subscribe to our channel for more amazing content. Thank you so much for watching this video. Please share the video with your family and friends, and we will see you in the next video.